Hey, good morning everybody. Thank you for coming along at 9 a.m. It's exciting to be here in Atlanta. My name is Paul Andrew. I'm a technical product manager on the Office 365 team. And I cover networking, data center performance for Office 365, and I also work on some of our new features that we're looking at for large multinational companies. And I'm joined by Paul Collins.
Hi everyone, I'm Paul Collins. I'm a senior program manager within our Office 365 CXP team, and I spend the vast majority of my time working with customers, helping them connect to our services and solving problems around the networking connectivity space.
So we're here today to talk to you all about cloud networking. What does it mean to connect to a SaaS service? And it really only matters if you have lots of users. You're not just a single user at home connecting to the internet. That's all going to work, right? That's all easy. We're here to talk to you if you have 1,000 users all doing it at the same time across the same network connection, and what does that mean? So that's the space that we look at. And we actually have 2 sessions today. How many people are joining us for both sessions and already know about that? A couple there. So we'll talk about, I thought we'd talk just a little bit about how we've broken these 2 sessions up. And the first session is what we want to talk through is a step-by-step how to go about implementing ExpressRoute on a particular customer implementation. So there's a few steps that we want to think about going through before you switch those network routes over to using ExpressRoute from using internet. So that's what we're going to talk through on the first session this morning. And so we've broken these up into 10 different areas, and we'll talk through each one individually, starting at what you do first, going all the way through to after you've switched over if you have to do some troubleshooting. So that'll be the first hour or so that we'll be talking. The next session that we have, which is at 10:45, it's over in Building B. That session is more sort of discussion topics around network routing and specifically related to ExpressRoute. So that's the session that will go into things like, well, when should you be considering using ExpressRoute direct networking versus just using the internet or some combination of the two? And by the way, spoiler alert, if you're going to be using ExpressRoute, you are using some combination of ExpressRoute and internet. There is no ExpressRoute only option for Office 365. We'll talk about different ways that you can do routing from your user PCs through your LAN to the perimeter network to get that split between ExpressRoute networking and internet networking. We'll generally just try to share with you some of the things that we've learned over the year or so that ExpressRoute has been out that people have gone through to do that implementation. So that's going to be our second session. We'll also talk a little bit about, in that session, some of the process that has evolved around ExpressRoute, around review of new customers that want to use ExpressRoute. We do have a process you have to go through to have the requirements of your network reviewed before we will say, okay, it's a good idea, you should go ahead and use ExpressRoute. And we have that review process so that we can help people to make the right choices about networking options that they have. So we'll talk about that in that session as well. Okay, so this session, we've got 10 steps that we're going to go through, and these 10 steps largely assume that you're ready to go. You're ready to set up ExpressRoute in an organization. You may have one or more locations with users. You may have a WAN across multiple buildings. You might just have a LAN. We want to think about what are all the things that you have to do in order to make sure you have a successful network update. So we're going to go through, and we'll switch back and forward a little bit, and we'll probably interrupt each other and add a little bit. We've been working together for a little while now on cloud networking. So we're going to talk to you about prerequisites before you get going, before you start one of these projects, what kind of requirements you want to gather from your organization that you're working with. It's never a case that the requirement is just to deploy direct networking. There are always networking requirements that you have to be cognizant of as well. We want to talk about a project plan that you might use to create this kind of project, how you would go about doing a network assessment and different types of network assessments that you might use, how to think about network security, where it's not just internet network security, it's not just your LAN network security, but it's something else. It's a direct network connection between your network and Microsoft's data center networks. So it's not really either of those, it's kind of something in the middle. We'll talk about an implementation plan to prepare, then perimeter network routing design, what goes in your perimeter network, LAN-specific designs, which is connection from users to that perimeter network, and then test and deployment plans, switching the routing on, and troubleshooting. So that's what we've got. Let's get going. All right. So first up, why? Why do we have to have an implementation project for adding direct networking?
Yeah, you might find that list we went through is quite a lot, because you may be already using ExpressRoute with Azure Private Peering, and it was pretty easy to turn on. You put the circuit in, you turn it up, you connect to your Azure Private devices. That's pretty easy, relatively easy. So it kind of looks like this. The changes that are required, once that circuit's in place, your chosen provider's put that link in, it's connected to Microsoft's network at wherever you've chosen. You can turn that circuit up, and you can either connect to your constrained VNet there in Azure, or you can't. It either works or it doesn't. If it doesn't work, then we can work through and fix that problem with the circuit. So there's relatively little change that needs to be done within your environment once that circuit's plugged in. But if you then move on to think, okay, Microsoft peering, which is the peering model used for Office 365, we want to turn that up and give that a go and see how that works. And this is where we get into difficulty, I think, because it's so easy for the Azure Private Peering that it's easy to presume that the Microsoft peering is as easy, and it is not. So when you turn on Microsoft peering, all those red dots indicate somewhere that you need to be thinking about changes and management. So that could be firewalls, proxies, routing tables, security devices, NAT devices. There's a whole array of things that need to be thought of before you turn that circuit on. Because if you don't manage those things before you turn Microsoft peering on, there's a very, very high chance of a complete outage of Office 365 in your environment. And obviously, nobody wants that to occur.
Yeah, so why is there all this change that's required with Microsoft peering? Where it's not required with the Azure Private Peering. What are we thinking about there?
Well, the majority of the work needs to be done because we're accessing public IP space. And when you open that second circuit to Microsoft's infrastructure, it's essentially a routing override to the internet path. So once you turn that Microsoft peering on, you have two possible routes to the same endpoint. The endpoints you connect to via ExpressRoute are exactly the same as those that are published over the internet. And the networking guys in here, we think, okay, we've got possible asymmetric routing problem, which we'll talk about later. And that's a very, very real risk that traffic will come in one way once you've turned that circuit on and come out of another. So there are a whole raft of things that need to be considered. And to work through this project, you think with Azure peering, you probably just need your network team to get that circuit spun up. When it's ready, you go, okay, put it live and we'll connect to our machines. But when we look at Office 365, that network team are obviously involved at that level, but then we need to start engaging other teams to ensure that every piece where that red dot was shown on the previous diagram is thought about, mapped out, and ensure that we're connecting in the right way. So that would be if you're using proxies for internet access. There's work needs to be done there to adjust the traffic, the allow list through that proxy, to ensure that proxy can scale up to cope with the traffic. Again, this is not an exhaustive list of what needs to be done here. Just trying to give you an idea of the teams you need to pull in to ensure success in this area. So on top of the proxy team, you'll need your desktop team engagement. How are you going to manage that traffic on a client? Are you going to use multiple proxies? We'll talk about your routing methods in the next session, but this will involve the desktop team, what software versions you're going to use to connect in the best way. How are you going to manage that pack file on the client to distribute that routing of the internet and ExpressRoute model? So that needs to be considered. You'll need the Office 365 project team will need to be involved, obviously, to plan through this. Paul will talk through a kind of typical implementation plan, which is normally led by the project team. They may need to configure things in the service to set up the service to work how you want it. Maybe now you've got the extra bandwidth, you want to change how Skype for Business works, the codecs used, etc. Policy setting. On top of the project team, your network architects are going to not just think of that circuit that we're putting in, or multiple ExpressRoute circuits. We've got to look at the whole network. How are we going to get that traffic from that client to the correct egress? Normally we recommend multiple ExpressRoute circuits for failover reasons. And for a multinational, that's absolutely going to be necessary. Or do we use the internet model for some sites? And a network architect needs to look at where it makes sense to use that ExpressRoute circuit, where we need ExpressRoute circuits, where we need the internet improving. All this work needs to be done in advance of turning those circuits up. Exchange, so some of the complications we see around hybrid environments. So that might be SharePoint, Skype for Business hybrid, or Exchange hybrid. And we'll talk a bit about Exchange hybrid in the next session around what happens when you put ExpressRoute in and you've got Exchange hybrid, because some connections need to come in to those services from our online services. So how do you manage that? Now you have two possible ingress points. Do you want them to come in over the internet, or do you want to use ExpressRoute? If you use ExpressRoute, what's going to happen to your users that are in Starbucks somewhere? So these things need to be considered. And then, last but not least, your firewall security team. I'll leave it to you to decide who argues with who on that bottom one, but it's a common thing that I get involved with customers, where the project team want to do something and the security team are slamming their hand down, quite often quite rightly. So these discussions need to be done well in advance of any circuit going live to ensure that that circuit is secured. Because one of the common misconceptions with ExpressRoute for Office 365 is that it gives you a security barrier. It doesn't. You're connecting to public infrastructure, you're connecting to Microsoft's infrastructure, and that still needs securing and thinking about in advance. Okay.
All right, so let's talk about prerequisites. And in prerequisites, what we're really talking about is there's some things you have to have before you start this implementation project. And this implementation project we're talking about is really about your routing updates that you're going to be making when you have direct networking. Paul C talked about you having a route both across an internet connection and across ExpressRoute, essentially to the same set of servers at Microsoft. Now, that's relatively straightforward if you have advertised routes to connect to those. But the thing is with routes are advertised from the server end, and you will connect from the client. And so you'll see those routes as a client, and you'll say, okay, I go this way. And so as a client, it's very easy to see those routes, and you get the priority, and your computer makes a great choice based on that priority to go either over ExpressRoute or over the internet. It's all very straightforward, very simple. But those routes have to happen both ways, and those routes have to be the same in both directions. So the routes are advertised by Microsoft, both over the internet and over ExpressRoute, and you'll get a higher priority route over ExpressRoute. The trick is, and Microsoft takes care of that routing, the trick is that on the customer side, on the customer LAN, you've also got to advertise routes to Microsoft. Why do you have to do that? There's two reasons. One is because there's got to be a return packet for every request. There's got to be a response. So if you send a request to a Microsoft server and say, I don't know, get me my email, there's got to be a response to that TCP packet, and it's got to go over the same path. The reason it has to go over the same path is because if your response goes over a different path, did we mention asymmetric routing? If your response goes over a different path, we have firewalls that are going to go, oh, I didn't expect this response because there was no request. Drop the packet. And that simply means your request for that email is going to fail. And as your user is sitting there running Outlook, they will just see that they get no email. So now we have these two paths. The other reason that you have to have those two paths set up correctly with route advertisements from Microsoft, route advertisements from the customer, is because Microsoft, and Paul mentioned this as well, makes some requests into the customer. Whatever those requests are, I think we talk mostly about this in the next session, but there are things like hybrid Exchange, hybrid SharePoint, ADFS. There's a variety of different things that a customer, anyone might have set up on premises that Microsoft connects to. Same thing has to happen. The Microsoft server has to connect to the on-premises server, and then the response has to go back the same way. So, prerequisites for all of that, and we're going to be talking mostly through how you get that right, how you make sure that routing is set up, and so that you have a good experience when you switch it over and everything still works. Before we get there, we have some prerequisites. And so what are they? I mentioned that there is a review process that we go through to make sure that there is a good use of ExpressRoute. We really don't want people having asymmetric routing errors and failing to connect. So we want to make sure that people appreciate that that's going to happen. We unfortunately get a lot of assumptions that this could just be turned on and it's going to work and everything's taken care of. And that routing change means that it is not. You have to do some work. And so there is a review process today that you have to work with the Microsoft Account Manager. We'll talk in detail about that at the next section. You've got to have an ExpressRoute service provider. The ExpressRoute circuit from Microsoft terminates at a network service provider, and so the customer that you're working with, or yourself, if you're the customer, you have to have a network operator that is a Microsoft ExpressRoute partner, and they run the cables from the LAN or the perimeter network that you have into the co-location facility with Microsoft. So there's the customer network, there's the network operator, the one network operator you work with, and then there is Microsoft's network.
And it's worth pointing out here that ExpressRoute circuit terminates at a peer point with Microsoft's global network. It does not go into the data center, which is a common misconception I run into, where customers think about their data in one location and want to run a circuit into that location. That's not how this works, how the internet works. The ISP or your ExpressRoute provider will run a circuit to an internet exchange and hand it to Microsoft's network, and then we get it to where it's got to go on our network from there.
Yep. So you've got to have one of these network service providers. You should read our documentation, both on Azure ExpressRoute, which is the networking technology that we work with. Paul and I both work in the Office 365 team. There's another great team in Azure Networking that actually do all of the software-defined networking technology that underlies this. We rely on them very heavily, but they do have a separate set of documentation which you want to read and understand. So we have documentation on the Office 365 side, which mostly focuses on the higher layers about network connectivity for our services. And it's super helpful if you have some good base level understanding of TCP/IP. If you've done work with TCP/IP any time in the last 25 years, that stuff's all pretty much the same. If you haven't, learn about it. Find a good book and learn about some of these protocols. It's really valuable to have a little bit of understanding of some of these routing protocols. So that you're not just relying on me waving hands of servers and clients and that sort of thing. It is good to get a bit of that background knowledge. So that's our prerequisites. What is up next? We're going to gather requirements. So we want to gather requirements because networking is not always the same. And something we've found as we've been working with a lot of customers connecting into Microsoft's cloud is that most networks, most LANs are different. There are differences that make it a lot of time spent asking people about how they've configured their LAN, how distributed it is, what kind of routing they have, how their PCs connect. There are a lot of differences there. And so gathering requirements is about learning about those differences, learning about what people are involved in the organization. Paul had this great slide showing the different teams that are involved. It's very common for us to get involved with one of those teams and then have to spend some time finding either the team that owns the routers or the team that owns the firewalls. We're always working with large organizations when you're talking about dedicated networking, and you have to make sure that you have the right people involved. Otherwise, those projects go pretty slowly. So another thing I've got listed here is cataloging outbound and inbound services. Now, there's an outbound service is really just a user and their client running Outlook or running OneDrive for Business Sync tool or running Skype for Business and making a TCP connection out into Microsoft's data centers somewhere. So that would be an outbound service. And these outbound services normally go through a proxy server that you have, maybe a firewall that you have, hopefully, before they connect onto the internet. And they're relatively well understood. And they typically, a lot of them go through the same paths. Maybe there's other devices in there which are intermediary. Maybe there's devices depending on what kind of protocol it is. But they're fairly standard across most customers. The inbound services are usually pretty different. And inbound services are all optional for Office 365. You don't have to have any inbound services. So sometimes we'll start working with a customer and they'll be asking me, the Microsoft guy, what inbound services do we have on our network? I don't know. What ports did you open on your firewall for inbound services? So inbound services, the people who set up the LAN and set up the firewall connecting into that LAN should know what those inbound services are. Irrespective of how you get there, we need to know what they all are because we're going to make a significant change to the routing for this network, and each of those inbound services needs to have a route advertised to Microsoft correctly, both over the ExpressRoute links and over the internet links, so that when those inbound services are being used by Microsoft servers, we will send requests over the right network.
And this is why you need multiple teams, because your firewall teams may have been asked to open these ports, and they don't ask why. They normally do, but you know, they'll ask why, and then argue a bit, argue some more, and then open the ports. But they might not know the exact reason why. So you'd need your Exchange hybrid engineer to explain, okay, we're exposing OWA, auto-discover, etc. to the internet. And we need to understand that, so that's why you need to pull those teams together to get a full end-to-end picture to understand, okay, how's this going to look when we put a second route out to these devices? How are we going to connect in and out?
All right, so next thing we want to know, and we're going to talk more in a second about inbound services. Next thing we want to know is what are the security requirements that you have on the network. Now, we're going to dive into security and how you address those requirements in a minute, but the point about gathering requirements is we want to know what kind of level of security is required on the network. The same thing for high availability. Are you concerned if there's a single point of failure on the network at some location, or are you not? ExpressRoute does a great job of removing single points of failure. When you provision ExpressRoute, we have an availability SLA for the Microsoft components. Many network providers who work with ExpressRoute also have those availability guarantees. And that's for Microsoft, it's a refund-based backed guarantee. So we'll give you money back if we don't meet that SLA. We achieve that SLA, by the way, by having no single points of failure. We run multiple physical cables. We have multiple routers at each location. We run double the amount of bandwidth that the customers are paying for. So if we have a physical outage of some kind, we're still able to deliver the bandwidth that has been paid for by the customer. So that's how we back that availability guarantee. But what are the high availability requirements? Do you need ExpressRoute connectivity in multiple locations in order to achieve the availability requirements you have? Do you need multiple in the same location to do that as well?
I'll give you an example of something that happened a while back, a few months ago in the UK, that I won't name the provider, but there was a centre went offline, an Exchange centre went offline because of a power failure, only for 7 minutes. But if your circuit is running there, we have no control over that. That's not our internet exchange. And it Didn't take Microsoft online because it was a section that we're not in. But you've got to think about that. What is your plan if you have a single ExpressRoute circuit and that provider's building has some sort of incident? Do we have a secondary circuit where we can switch that traffic over very quickly, or have we got policy to switch that traffic over to the internet until that circuit's back up? So these need thinking out well in advance so we can plan those extra circuits, the bandwidth, etc.
All right, so here's a list of the inbound traffic types that we most commonly see. ADFS, Active Directory Federation Services, various Microsoft servers, Exchange Server, Azure AD, connects into ADFS on-premises servers in order to do password or security validation for users signing in if you're using ADFS. Exchange Server Hybrid, inbound. Email from Exchange Online to maybe an on-premises email server if you have an SMTP MX endpoint that's on-premises. SharePoint online mail, if you have on-premises email again, then you've got a mail host on-premises accepting that. We've got SharePoint Federated Hybrid Search if you're using that, or if you're using business connectivity services. Skype for Business Hybrid, Skype for Business Federation, which both would have servers on-premises in the customer organization for being connected to. And then Skype for Business Cloud Connector. Not one I'm familiar with, but it also involves a server on premises that will be connected to from outside. So all those inbound flows, they are the high-risk ones typically for this asymmetric routing problem. And they're typically higher risk because you've got to actively make a routing change and advertise routes from on-premises to the outside. And those route updates are pretty different for teams that are familiar with having just internet connectivity. If you just have an internet connection, your routes are pretty straightforward. You're advertising a route for everything that you have on premises out that one internet connection. As soon as you have this separate dedicated route, your advertisements get a lot more complicated. All right, another prerequisite we want to do is get hold of network topology diagrams. A topology diagram is really critical to be able to figure out how am I going to set up this routing, what are my IP addresses that I'm dealing with, and therefore, how am I going to do either my BGP or my other type of route advertisements. So we're going to look for, when we get involved in these projects, we want to see these topology diagrams and understand really what the routing is happening on the network. So here's an example of one that we put together. We published this diagram on support.office.com, where, by the way, we have an article that talks you through all of the same stuff that we're talking about, this implementation plan. So that's online. And this is really helpful for someone doing troubleshooting of the routing or for planning of that routing to have these kind of diagrams there.
And it's also worth going through your inbound traffic flows that we just talked about and mapping those onto a diagram, so you can either provide that to someone else if you need support or just for your own reference, so the whole team can look at and understand how that traffic flows in and out of your environment.
All right, next up, Meet Me or co-location facilities, Meet Me locations. So you've got to figure out where you want to have your ExpressRoute connectivity go to meet with Microsoft. We have a few dozen of these locations around the world today where ExpressRoute connectivity comes in. By the way, if you're thinking about an ExpressRoute or direct networking versus all internet or versus some internet only and some ExpressRoute plus internet, we have 2 or 3 times the number of co-location facilities where we have internet connectivity.
65.
65
I counted them the other day.
65. So 65 locations around the world where we have internet connectivity from Microsoft's global network. We run cold potato routing instead of hot potato routing. So we will attract traffic onto Microsoft's global network if it's connecting to our servers. Why do we do that? Because we want you guys to have a great experience and have good performance, and we put a lot of money into our network, a lot of excess capacity. So we advertise routes to get that as quickly as possible onto our network. If you're internet connected, 65 locations where we can do that. ExpressRoute, you have to choose. And if you're going ExpressRoute as much as possible, you want to have as many as possible locations where you connect in so you get into that Microsoft network and let us route your traffic around the world. You can literally have an ExpressRoute connection in Australia, and we'll route your traffic from Australia to wherever the data center is that you need to connect to for Microsoft. And if you have users in Europe, you can connect onto our network in Europe, and we'll route your traffic across that as well. You don't have to traverse the internet with your traffic or have connectivity across the world to where the Microsoft data center is that you have.
You know, I talked about this a little bit yesterday on my talk around trying to reset kind of thoughts around the internet. And the service is designed to work over the internet primarily. And we have those network peer points all over the globe. So when you think about traffic traveling from the edge of your network to ours, that's the internet leg. And hopefully that's very short. I did a demo yesterday from here. There were 6 hops from here to the Microsoft peer point, which happens to be in Atlanta. So Comcast is the ISP here. We watched the trace go out and peered with Microsoft's network in 1 millisecond. So that's the sort of thing we need to think about in terms of the internet, that we're only on the internet for that very short leg, hopefully, to where you'll meet Microsoft's network, and then we take it from there. And ExpressRoute is purely a private connection to that peer point, or one of those peer points.
So there you go. First, the first peering point we have there listed is Atlanta. We have ExpressRoute peering and internet peering somewhere around here. All right, we will move on. So number 3, actually we're at 3 and we're 30 minutes in, notice. So number 3 is a project plan. We encourage you to have a project plan for doing these routing changes. I got an example here in Microsoft Project. Network assessments, selecting an ExpressRoute provider, learning about the configuration, gathering requirements, planning outbound services, inbound services, setting up a test plan, a deployment plan, deploying during an outage. That's always interesting. When you're making a routing change, very often you're doing it on the production network. And so by definition, you've got to have a network outage in order to do that. And then in order to test that everything's working and potentially roll back. So we'll come back to that in a little bit. But let's move on to network assessments. Turn my microphone back on. So I'll talk a bit about what we need to look at in terms of network assessments here. So as you might think, networks are quite important for cloud services to work well. So we always encourage an assessment before any move to the cloud, any change in your connectivity to the cloud, and that would include putting an ExpressRoute circuit in. So you've got a full end-to-end view of what your options are and what the best connectivity methods are. So from a Microsoft perspective, we offer a number of services to do this. We have a massive amount of partner deliveries that will do this for you as well to ensure that your connectivity end-to-end is as optimal as possible. But which kind of service you need depends on what you're doing. Bandwidth planning is always the first thing that should be done because, 1, it takes a long time to do, and 2, it takes a long time to order new bandwidth for circuits in a lot of cases. So from a Microsoft perspective, America's Cloud Services, MCS might be able to come in and do this work for you. We publish calculators online to help you understand what bandwidth is used by services, but those are only as good as the data you put into them. And we generally recommend using measurement of your pilot users or measurement of the traffic going in and out of your on-premises Exchange environment and mapping that out and using that data to put into the calculator. In terms of connectivity, making sure that your sites are connecting to Microsoft in the best way and that your egress equipment isn't changing things that are causing problems or causing bottlenecks. Premier deliver a network performance assessment where they'll look at a number of sites for you and say this site is not connecting optimally, it would be better to switch it here, or this proxy is doing this to your traffic which is throttling your throughput, etc. So that would be, if you were having performance issues, they would be able to point out where that is, or it's worthwhile running those in pilot to make sure that your connectivity model is optimal. When you're looking at Skype for Business, that needs a very specific assessment because the Skype have an excellently detailed framework, the Skype for Business framework. I think there was a session earlier on this week on it. Essentially, they will map what the requirements are in terms of network connectivity for a high-quality call video meeting.
So that means from the client to the edge of your network, X amount of latency, X amount of jitter, etc. From the edge of your network to Microsoft's network should be this, and then end to end. And they've published a tool earlier this week to do that, a publicly available tool where the tool will check all those things for you. So it's worth running that yourself if you're comfortable with that, or Premier should have a delivery very soon where they'll come in and do that for you and help you understand the output. So those kind of assessments fit different requirements, but when you're looking at ExpressRoute, you really need to be thinking about how each of your physical sites are going to connect once those circuits are put in, where those circuits need to go, where's the optimal place to put them, and whether you've got outlying sites that it does not make sense to use ExpressRoute, keep them over the internet. This sort of planning needs a network assessment to figure out where those lines lie. So I've just talked about bandwidth in terms of how we recommend it, but there's a great link there, the aka.ms/tune MSIT. It goes through how Microsoft IT planned this. As you can imagine, we're quite a heavy user of our cloud services. So MSIT came up with the approach, it's outlined in detail in that link, but essentially they came up with a figure of
400 kilobits.
400 kilobits a second. And then they just extrapolate that out by the amount of users in that site that they're going to connect, and they work off that. That works out to a very high level of bandwidth, which is what we work to. And if you have 2 users in your office, it doesn't work overly well. But it's a nice starting point if you're an enterprise getting towards the size of Microsoft and using the level of cloud services we do. And the Skype for Business framework I mentioned before is also linked there. Again, if you're looking at Skype for Business online, it's absolutely necessary to work through that to make sure that your call and audio quality is going to be as the Skype team intend it to be. So security, I mentioned this earlier on. It's a common discussion I have to have with customers around when they want ExpressRoute, whether this is a driver for wanting ExpressRoute. They don't want their traffic on the internet. So we address this because the security required for ExpressRoute, it does not go away as a requirement. So if you look at that top kind of bullet point there, the way we see it is the internet requires your highest level of security policy for obvious reasons. That's what you already do, and you're doing it very well. Office 365 ExpressRoute sits somewhere in the middle between that and connecting to your on-premises data centers, so a WAN link out to your data center, or Azure IaaS, where you'd read a limited amount of security policy because of the way that's connecting to an isolated environment. So Office 365 sits in the middle there, so it's not something you can just forget, but it maybe doesn't need the level of intrusion detection, all that sort of stuff that is done at the internet level.
And I think we kind of see this because most organizations are familiar with internet security requirements, and lots of companies have a policy around network security for connecting onto the internet. And there's typically a lot of detail around that policy of what the requirements are, what kind of devices are required, and it's often you spend a lot of time on that. And what we're saying is, well, you're not connecting to the internet in this case, you're connecting to Microsoft data centers, and don't you trust Microsoft? So it sort of stands to reason that you would have a different security policy for doing that than connecting directly to some random internet site, which of course is a policy people are familiar with. And I think what we tend to see is because it's different and it is a lower security policy, we see people go to, oh, I don't need any security if I'm doing that. And what we want to tell you is there is a level of security that you want to think about. You want to understand what are all the risks that you're protecting against on the internet. Some of those maybe have gone away. Microsoft is a known company. You have contracts with us if you're connecting to our servers. And so some of those risks have gone away. Other risks which you have a security policy in probably have not. So this is different, and maybe a different level of security policy, as Paul was just talking about, is needed, and something that is a little bit of time worth thinking through. Or you can ask us for advice about what we think. But, you know, it's not just no security, and it's not probably the same security as you have on the internet.
Yeah, and often I run into things where customers are trying to implement security policies when it's worth having a look at what Microsoft does in the back end. Are we providing something in the back end in terms of security that negates the need for equipment at the edge of your network to do that? Because that could cause a bottleneck. It's always worth looking at this in depth and what we're doing and what you're doing and make sure those two things fit nicely together. So with ExpressRoute for Office 365, it doesn't prevent DDoS attacks. What we're referring to here is that the internet is still required. So let's say you're loading a SharePoint page. Elements of that page, i.e. not your data, but scripts, generic images that aren't yours, might be loaded from a CDN over the internet. So if that internet pipe is blocked for whatever reason, then you're going to get performance issues, even though you can get your data for the page over the ExpressRoute circuit. So it doesn't prevent that from being a risk factor. We don't lock down, well, there's no way to lock down, given it's a public distributed architecture, access to other Office 365 tenants. So your users, in theory, can, from their machines, connect to any Office 365 tenant because it's an end-to-end connection to our network and all our services. It doesn't replace the need for proxy servers if you use them, load balancers, firewalls. Those are still required on the internet pipe and to a certain degree on the ExpressRoute circuit. The circuit also doesn't provide SourceNAT. So your connections coming in from Microsoft need SourceNATing in most cases, and your connections going out from your environment need NATing on the way out because you've got to addresses with public IP space. And if you have specific inspection filters running for whatever reason, it doesn't replace that, but sometimes it might do that. DLP in our back end might prevent you having to do that in your environment, as I said earlier on. And one of the pitfalls we see customers run into quite a lot is using the URL and IP list page that we have to block access to anything that's not on that page to the ExpressRoute circuit. That should not be the way that you manage this circuit because that page is not dynamic enough. We try and update it well in advance of any IP change, but given the way BGP works and occasionally we have to do emergency IP changes for whatever reason, then that's not a dynamic enough process, or your security team might be on holiday and miss the RSS update. These things happen, and they do happen a lot. So to protect that circuit, you've got multiple ways of doing that. You can use max routes if you're worried about the route flooding. You can limit that to Microsoft's ASN, or we publish a full list of our CIDRs. So that's every IP address Microsoft owns. So you can use that as a list. That doesn't change in anywhere near the rate that the URL and IP list for Office 365 does.
Yeah, you can't really get more IPv4 addresses these days.
No, not cheaply. And that kind of policy needs to be done on every ExpressRoute circuit that you're looking to implement. So you can see this stuff takes time. It's not as simple as just turning that circuit up, as I said. So the way we've just described it there, you've got three types of peering with Microsoft ExpressRoute. You've got Azure Private Peering at the bottom there, which is essentially an end-to-end connection to your constrained environment. That is where you would need the least amount of security, because that's an end-to-end tunnel to your restricted environment. In most cases, you're not able to get out to the internet from there unless you put a route out. The Azure Public Peering and Microsoft Peering, as I've just gone through, need a level of security to ensure that your environment is protected when you're connecting to those two services. Okay.
All right, that's security. We're going to talk about an implementation plan. So the idea with an implementation plan is we just want to think about writing down what we're going to do for these routing changes before we go ahead and do it. So we've got a plan for bandwidth requirements, a plan for what we're going to do about security, what we're going to do about the high availability requirements and failover. And then we want to have a design written down for outbound connectivity and then for each of the inbound services that you have for the organization. All right, so we're going to write that down so that we can think about it, maybe have someone review it before we decide to go ahead. How far is ExpressRoute route advertisements going to be propagated within your network? This question is really about Are you using BGP across your network, or are you just receiving BGP routes at the network edge and then using some other kind of protocol or some other mechanism for having that routing get back to the PCs that are in the organization?
So I'll talk about the most common ways we see this being done, your options here in the next talk in more detail.
Right. So then DNS, you're going to have some changes for your DNS related to the routing changes potentially. Your NAT strategy, Paul just talked about NAT. You've got to have NAT in order to be able to provide public IP addresses. There's a few restrictions ExpressRoute has around IP addresses and NAT pooling and not sharing those. And that's again related to so that we can have route advertisements for those IP addresses go over separate circuits and not have requests and responses go over different circuits. Your network topology update, it's always great to do a paper verify of these network topologies. Sometimes we'll even do this on the phone with a customer if they're having a problem, is ask, okay, where does your inbound service for ADFS hit your network? What is the server? Okay, it's this IP address, it's in this location. What kind of routes are exposed to that server within your organization? Where does the traffic go after it hits that load balancing server when it comes inside your network? Paper verify is just essentially about thinking about each of those inbound and outbound services and saying, okay, what hops does that make across my network? And making sure that the routes that are available to each of those nodes are what you expect. And when you do a trace route, that's going to match what you have done with paper verify. I like paper verify because you can actually follow it all the way, whereas with trace route, very often you get blocked here and there and you just can't follow it. Also, you're only following the forward path, you're not seeing the reverse. So although it's real, it is very limiting in what you can see. All right, so availability and performance. Dedicated circuit does not equal a security barrier and does not equal high availability. So we kind of talked about this a little bit already. You want to plan for these kind of things and make sure that your plan has no single points of failure. Assuming high availability is critical to you, and make sure that if there is an outage, that you're minimizing the impact and minimizing sort of the blast radius of that outage that you have. All right, let's move on. We'll talk about perimeter networks.
Okay, so these are some of the kind of design things you need to think about around perimeter networks. We've kind of talked already about where those meet me locations are. Trombone route avoidance, that's referring to what you don't want is put a massive 1 gig pipe in somewhere and forget about the local LAN links, because that's going to have a bottleneck that goes through and then spits out into a large circuit. That circuit can be large enough to cope with all the traffic, but if the end-to-end bandwidth availability isn't good, then we're going to have performance issues. Using multiple meet me locations, absolutely recommended. Can you use a single ExpressRoute circuit? Yes. Should you? Probably not is the answer. Or at least have a very good backup plan to switch over to the internet. So have a look where those termination points are. Obviously, there's no real point in putting 2 ExpressRoute circuits into the same meet me point. So some cities, London being an example, we have multiple places where you can run circuits into, or I'm working with other customers that have one in Europe, one in the USA, and if the Europe one goes offline, their BGP routes will switch that over to the US. It's not an ideal scenario, but hopefully that downtime on that Europe circuit is pretty short, but we're not going to have a complete outage of connectivity during that period. We can still connect, albeit slower than we were doing already. So these things need planning, think about it. This is why your network assessment will show you where that would be necessary. And of course, the internet is always an option for you if you've got that capability to switch that over quickly. Avoid routing traffic to different continents. I'll give you a story. I worked with a customer the other week that put an ExpressRoute circuit in the USA on the East Coast. And they turned that up, and then they set the BGP routing up to their APAC site to use that ExpressRoute circuit. Previously using the internet in APAC. So we pick that traffic up in APAC on our network and get it to where it's got to go. Now, when they put that circuit live, all that data in APAC was having to traverse their MPLS over to the east coast of the USA to go out to the internet, to hit Microsoft's network, and then go to where it's got to go. So that is not optimal connectivity, and they had some serious performance issues there, partly down to their DNS setup, which we'll kind of cover later in this one, or on the other one, I can't remember where that slide is, but it's around how Outlook tries to connect to local endpoints. But you can see the point here that we've got to think about this traffic flow and ensure that we're not actually, by putting this premium circuit in, we're not actually causing a negative impact to some of our users. We've already talked about inbound services. You've got to understand every inbound services. As I said, we'll talk about Exchange in detail later on around what needs to be exposed to the internet, because, for example, if you don't expose Auto-Discover to the internet, your users aren't going to be able to connect in and get their mail. So there are considerations around that. So we need to understand the traffic flows and what happens if we don't expose those to the internet and we use ExpressRoute. Outbound services, we thoroughly recommend using separate NAT pools on all your ExpressRoute circuits, so non-overlapping NAT pools on the internet and your ExpressRoute circuits. Why? It protects you from asymmetric routing. It means traffic that goes out of that circuit will be sent back to that circuit, and it ensures that your firewalls aren't going to run into that scenario where they don't see the inbound packets or don't see the outbound packets or drop the inbound. And internet egress requirements. I'll talk about this a bit more in detail, but you've still got to take care of that internet piece. It can't be forgotten when you're moving to ExpressRoute. It's still vitally important to your performance. There's my slide I was thinking about. GeoDNS. So I explained in my session yesterday in more detail around how Outlook, we have a GeoDNS system which allows Outlook to connect to a CAS server in the region where the user is. And we do that by looking at the DNS call and figuring out where that DNS call was sent from. And we can say, okay, this was done in Europe. So even though your tenant might be a North American one, that user in Europe, your office in Europe, will hit a CAS server in the European data centers. And then we backhaul the data from there. Now, that works nicely if that DNS call is being completed in the right place. So imagine that scenario I just talked to you about where we've spun up an ExpressRoute circuit in the USA. So that's my internet egress point for my APAC users now. But what they hadn't done is change the DNS call so it completes in the USA. So what was happening is the DNS call completed in APAC. We get a list of CAS servers in APAC, but now I've changed my egress point to East Coast of the USA. So the traffic has to go to the East Coast of the USA, into Microsoft's network, where we look at the endpoint and say, that's a CAS server in APAC. So we connect it all the way back to APAC, where that user first started. That is massively suboptimal connectivity, as you can imagine. So these things need to be thought about. I have a blog post, which is linked on the Tune site, which should be linked at the end, which walks you through how to check GeoDNS. But the simplest way to think about this, your DNS calls for Outlook.office365.com need to be resolved in the region where your egress is, and that egress should be in the region where your users are anyway. I kind of touched on this earlier on. SourceNAT is thoroughly recommended for incoming connections, so we can ensure, as I say, it's a surefire way of ensuring that traffic gets sent back the same way, because we have to respond to where that address is. So from an Exchange hybrid server, for example, something comes in from Office 365, that SourceNAT device will flip the IP address to the internal address of that SourceNAT device and send it to Exchange hybrid, who will then respond to the internal address of that SNAT device, which will then send it back out the same circuit. If you don't do that, imagine a scenario where it comes in over the internet. We've not source-natted that connection. So when Exchange sends the response back, we'll see an optimal route via the BGP circuit, the ExpressRoute circuit, to get back. And that's where the traffic will go, and you run into this asymmetric routing problem. So any devices, I mentioned earlier on about the URL and IP list. So this might be your PAC file, or any devices using that on the internet pipe, for example, need to be kept fully updated. Because if you miss things off, then you're going to get intermittent connectivity issues. To help in that area, I've written a pack file which very clearly shows you which URLs are required for ExpressRoute and the internet, because it can be a challenge, as probably a lot of you are aware. Who's looked at that URL and IP list? Just, well, some of you. Well, there's a big list there, and it's very complicated because we have to expand those out per service, and there's a lot of overlap. So anyway, I've written a pack file which very clearly outlines what's required for ExpressRoute and what's not, or what can be sent via ExpressRoute, and we'll publish those either the end of this week or early next week. You should be able to just grab those, and we'll keep them updated when that page gets updated.
I'll just talk about the SMTP inbound mail briefly. If you run an on-premises MX resolved SMTP server, then you should not advertise a route to that specific server to Microsoft over ExpressRoute. You need to advertise that over the internet. And the reason is, although our Exchange Online servers, you will get routes advertised over ExpressRoute, you can also connect to them over the internet, of course. You will not get routes advertised from any front-end servers for Microsoft Hotmail or consumer email services. And so if you advertise your SMTP server over ExpressRoute to us, that route will be part of Microsoft's core network. And so those consumer email services that we have, which also run on that network, will be able to see that route, and they will try to send any email from Microsoft Consumer Services to your SMTP host over ExpressRoute. And so what's going to happen is the response for that send packet, the response is going to go over the internet because you do not have a route to our consumer services over ExpressRoute, and so that's going to result in email not getting through. Troubleshooting a mail not getting through is very different to troubleshooting a route error, and so we have to make sure that you advertise those over the internet. So that's a good tip for how routing can get much more complicated than you expect pretty quickly.
And we'll talk a bit more about that exchange flow in the next session. So I also touched on earlier on around restricting that traffic coming in from ExpressRoute, securing it. So as I mentioned, don't use that URL and IP list to do that because it's not dynamic enough. There are various options I talked about before, using the full range of IP addresses, etc. What you can do is use BGP communities that are listed as preview, but they're working and live. You can use those to restrict packets that are tagged with Microsoft's Office 365 communities. So I'll talk a little bit about your LAN choices because this is going to be covered in the next session, but what do you still need to get to the internet? DNS name resolution for obvious reasons. That has to get out to the internet. CRL checks, again, for obvious reasons. You'll see most of these are not held in our data centers because it doesn't make sense to. So Office Pro Plus, CDN data, CRL checks, we can host that much closer to you in CDNs. We use our own Akamai's as well. And obviously, there's no point routing that into our network and out. It has to go out to the internet. Yammer, because of the way it's hosted currently, has to go over the internet. Office Video, because I think the data's held in CDNs. That's the reasoning for that, or some of it.
It's actually in Azure Public.
That was it.
Storage.
So these things obviously need to be mapped to the internet, and you need to, if you're using a pack file to separate that traffic, we can take care of that in that pack file. As I say, we've just published some, or we're about to publish some. So your connectivity options, how do you get your traffic? You put an ExpressRoute circuit in. How do you get your traffic from your client to that ExpressRoute circuit? And this is the complicated piece. I sat down and we worked through what the options are. There's thousands of different kind of methods that you could use, and every customer's network is different. But if you boil them down, you can have direct network connections with BGP, direct network connections with default routes, so we make a routing decision at the edge, or we use a pack file to send that ExpressRoute traffic to a proxy. So I'll run through these in more detail in the next session.
All right, validation, test, and implementation plans.
I was just going to say, if you can't make the next session and there's another one you want to go to, these are all recorded and available online, so you'll be able to watch it at your leisure at a later date.
So the thing about making a routing update is it's like anything. You've got to make the update, and then you've got to figure out, well, did it work? And sometimes the issue with making a routing update is you're actually doing it on your production systems. So I want to talk a little bit about testing for a moment. And part of your implementation plan needs to be, how am I testing that my routing changes that I'm about to make are going to work, are going to result in my users still being able to connect to the internet, still being able to connect to Office 365, that all my inbound services are going to work. So what are we going to do? I've got 4 ways that you can test those routes. The first, and I mentioned this earlier, is to do a desk check. So sit there with your network topology, with your routing information, couple of people, get them together, talk through what your routes are for each of your outbound and inbound services. Anything that's different, talk through them one at a time. Make sure you can convince someone else that they're correct. The second way that you can do testing is to test on a test network. We don't find test networks very often. Some customers will have test networks. We're basically talking about you have a separate connection to the internet from a test LAN and a test perimeter network and a test ExpressRoute circuit. A lot of people don't want to invest in doing those. We do come across them now and then.
I've seen a few recently, but
Yep.
where they use various methods. They can put that circuit, the ExpressRoute circuit, live, but prevent any of those BGP routes from filtering into anywhere but a particular segment of their LAN which is used for test.
If you don't have one, they're pretty expensive to set up because you're duplicating a lot of equipment. But a test network means you can make any routing changes you want and you're not impacting production users. The third way that you can test is, if these are just routes that are going to impact Office 365 and Microsoft data centers, do it before you deploy Office 365. Because then if you make routing changes and they potentially impact an Exchange server or something and no one's using Exchange yet, it just doesn't matter. So you can do this kind of pre-production testing as well. The fourth way, which is kind of the catch-all because you can always do this kind of testing, is to test during a network outage. Some of the best deployments I've seen have been where people have planned for multiple network outages on weekends, like 4 weekends in a row. They will plan for multi-hour Saturday morning network outages where no one can be in the office using the LAN because we're changing the network. And the first time you go through, you make your network routing changes and you go and see what worked. And you find there's a whole bunch of services don't work. So you write those down, you put the network back, and people come in Monday morning. Then you've got another week to go through and figure out, okay, what did we do wrong? What do we want to change? And then your next weekend comes up. If you plan for those in advance, then it's a great experience when you go through and you did what you said you were going to do. You had a network outage, you found some things that were wrong, you put it all back, and your users are okay again. And you can hit your deadlines for getting your network up that way. It does take a little bit of time because you've got to plan for all of these things, but you can always do that regardless of whether you have a test network or any of this other kind of stuff. So 4 types of testing. You absolutely want to do testing. If you don't do testing, there's a really good chance that you'll make these routing changes and it won't work as you expected, and you'll start to get those support calls come in. So I can't stress this enough. Testing before you go live. The last thing on implementation is just to have a plan for deployment and validation. After you do these routing changes, just go through and test all of the connectivity that you expected to have. This is where it's also valuable to have a list of inbound services. You don't actually need to test a lot of different users can send email. You just need to test that one user can send email. And then you want to test that that user can receive email. So test all of those inbound services. You don't need to have a huge broad test there as well.
You could use the pack file that we're going to publish, which lists those URLs very clearly with the express routable URLs, and just do trace routes to them from your different network segments to ensure they're traversing that BGP circuit as you expect.
All right, and our last step is troubleshooting, and I'll hand over to you.
So some of the common things we run into where we have to help customers who have issues here, we've mentioned it multiple times, we're not mapping out or not knowing about those inbound services. So that should be one of the first things that you do. Make sure you fully understand what's open over the internet. Are you going to keep them over the internet? Do you want to move some to the ExpressRoute circuit? If you do so, what is the impact of that to your users that are outside your environment? A common one we need to walk into as well, another driver for ExpressRoute use is they want to stop using the internet. that is still required, as I've mentioned. The vast majority of our core services, your mail flow, your SharePoint data, your OneDrive for Business data, your Skype flow, will go over that ExpressRoute circuit, and we explicitly outline on that URL and IP page what does and does not go over ExpressRoute. I kind of talked about it a bit earlier on. But the majority of services that require the internet are things that aren't hosted in our data centers. An open routing network. So I'll talk in the next session about the complications of allowing BGP routes all the way into your environment and the extra work that needs to be done to ensure that the traffic goes out the way you want it to. Not using SourceNet, again, this is a real common cause of asymmetric routing. I can't count how many times we've run into this problem and support have had this issue. And it's very hard with someone that doesn't have a technical network background to actually troubleshoot this. They just know it doesn't connect, and they follow the path they expect, and eventually we figure out, okay, it's coming in here and going out here. So using the correct source NAT pool, and our online guidance walks you through what's required here. If you do that correctly, you should prevent that issue from ever occurring. Not testing, as Paul just said, common where we fall into things that we would have picked up during testing that if that had been done. And a rare thing, but
maybe only once.
Paul's had it once, I'll let him explain.
Please don't use an Azure trial subscription for your ExpressRoute circuit. This may have only happened to one customer ever, but I did have to help them with it, so I'll tell you the story. If you use an Azure trial subscription, these things expire. And so I was working with this customer, and they called up, and nothing was working. Their circuit had gone down. It turns out what happens when the Azure trial expires is your ExpressRoute circuit will get torn down. And because this is all software-defined networking, the network provider's circuit will get torn down as well. Everything goes away. You have to start again and create all of these things from scratch. So please try not to use an Azure trial. At least don't have an Azure trial subscription that expires on the day you're trying to go to production. That was the issue here. So, I'm sure that will not happen to any of you.
Paul gets all the fun ones. So a baseline of connectivity. So regardless of route, connectivity to Office 365 services should work. So as I said before, we've got a public IP infrastructure, and the ExpressRoute circuit is purely a routing override. So sometimes when I look at this, if we miss a URL in a pack file, what happens? It should hopefully be caught by a catch-all and sent via the proxy. So it'll still work until somebody catches that and fixes it. That's the kind of scenario we want to be in. And when you're designing your network flow, that if something is missed, hopefully that's going to switch to your internet path, and then it should still work. The URL and IP list I've talked about 1,000 times is the link there. And it has a column in there that says yes and no, whether that service, that URL goes to ExpressRoute or not, i.e. we can route it via ExpressRoute. And as I say, we're going to publish that pack file, which, because that page is enormous, you should be able to just read through that pack file and see the consolidated list of URLs which can go via ExpressRoute. Okay, and in terms of the actual circuit itself, often when you have a problem getting the circuit up and live and provisioned, it would be a support call to one of our Azure networking team, and they should hopefully relatively quickly be able to fix that for you. The only state you want to look for in terms of that connection being live is provisioned and enabled. How do you know it's working? A trace route, see if the traffic's traversing those particular routes. You should see the routes come in, the BGP routes come into your environment. There should be around 600 come in. Your network team will certainly notice that when it happens. PS ping to Office 365 resources, I'm not sure that's a really good troubleshooting step, because it could be that your traffic isn't going via ExpressRoute as you expect, but it is connecting over the direct internet path. So, but at least it shows that that service is connectable in one way.
If it doesn't work.
Yes, exactly. A trace route would be your better option there. Prefix validation, I'll talk about here. We obviously check that the addresses you're advertising to us are owned by you. And if that's not done, you can't make the circuit live. That is pretty instantaneous. We check with a multitude of places to ensure that's the case. But if you're in a situation where you don't actually own your IP address space, you wet lease them off an ISP or someone else, and they're registered with someone else, it's very wise to do a support call to Microsoft in advance of putting the circuit live, so we can do those additional checks for you and confirm with the owner that it's okay for us to to let you use that address. And that's for obvious reasons, that we don't want to allow somebody to use somebody else's IP address on these circuits. General connectivity failures. Quite often these are purely asymmetric routing. Again, if you do that source NAT correctly, that shouldn't occur. Over-deliver there, as we say, if the traffic isn't going via your ExpressRoute circuit, for whatever reason your routing or your pack file is incorrect, hopefully that will go via the internet and you can pick that up and then switch that over and resolve the issue. And with that, here are some of the links to walk through this. There's the implementation guide, we've got the second link there, is very detailed, and the whole team of us wrote that based on customer issues, successful customers, and it's a really great resource for you to just step through, and it might make you think, we forgot that bit, and walk through it. So I'd thoroughly recommend having a good read through that, and it gives examples of NAT examples through ExpressRoute, and all the other complications and issues and the things we just talked about in the last 70 minutes. With that, we have about 5 minutes left for questions. We should be here for about 5 minutes afterwards, but then we've got to hot foot it over to the other building. But please, if you have any feedback about the session, please fill in the eval. And if there's any questions, please step up to the mic, someone will answer them. Otherwise, we'll hang around here for 5 or 10 minutes and answer them one-to-one.
You can also contact us later. On Twitter, I'm at PNDRW. Love to hear from you guys. Love cloud networking. Really appreciate you coming along and listening to us talk about it today.
Thank you.